my name is Najwa Shazwani binti Rosli. Today we are to present about the topic band pass filter. What is band pass filter? Band pass filter is a combination of both low pass filter and high pass filter. The name of the filter itself indicates that it allows only a certain band of frequencies and blocks all the remaining frequencies. In audio applications, sometimes it is necessary to pass only a certain range of frequency. This frequency range do not start at 0 Hz or doesn't end at very high frequency, but these frequencies are within a certain range, either wide and narrow. This band of frequency are commonly termed as bandwidth. The RLC series resonance circuit provide a bandpass filter when the output is taken off the resistor as shown in figure 1. Here is the circuit of bandpass filter that have inductor, capacitor and resistor. So here is the graph of bandpass. It is increased at omega. So next, the theory part. The bandpass filter plays an band of frequency omega 1 less than omega 2, certain on omega 0. The center frequency which is given by omega 0 equal to 1 over square root LC. A bandpass is designed to pass all frequency within a band frequency omega 1 less than omega 2. Since the bandpass filter is figure 1, the circuit of bandpass is a serial resonant circuit. The half power frequency, the bandwidth, and the quality factor are determined like before. This is also the frequency for which the impedance of the capacitor and inductor cancel, leaving only the resistance. Thus, maximum current can flow, leading to the maximum voltage across the resistance. This circuit only allows a small band of frequency near its resonant frequency to pass through, hence leading to its name. Okay, that's all about the introduction and theory for bandpass filter.
For the second part of the question, it is the procedure, and for now we are going to take a look at the few steps being followed in the procedure. For the first step, the main components used are being listed, such as resistor, capacitor, and also inductor. The values of each component used are also listed, whereas the other components used in the circuit construction that are not mentioned here are oscilloscope and also function generator. For step 2, the transfer function for band pass filter is derived by applying the voltage divider method, and the equation is expressed in terms of j omega. Frequency response, also known as magnitude, is evaluated, while phase frequency response is also evaluated but only using the imaginary part. For step 3, we are going to determine the type of transfer function being used in the circuit. This allows us to obtain the ratio of the output voltage to the input current of a mesh in a network. For step 4, we are going to derive F0. F0 can be derived by using the formula of 1 over 2 pi RC. For step 5 and step 6, it is going to involve the circuit construction. We are going to use Multisim software 14.2 to construct and simulate the circuit in order to acquire the result. In the later part of the video, there is going to be a more detailed explanation on how we are going to obtain the output voltage by using an oscilloscope. The step is repeated by using frequencies from 1 kHz to 10 kHz, and the output voltage is measured. The data obtained is then tabulated and analyzed, and it can be observed that at 5 kHz, the output voltage reaches its maximum voltage. The last step, the result for each varying frequency for the output voltage is attached to allow checking of the reading.
Assign the value for the passive component. Each value of every passive component is assigned a value. There are three passive components used in this bandpass filter circuit, namely resistor, capacitor, and inductor. The value assigned for the resistor is 12 ohm, while the value of capacitor is 0.33 micro, and the value given in inductor is 3 milli. The transfer function H omega equal to V output omega divide V input omega. Omega equal to 1 over square root LC. The transfer function for bandpass filter is derived by applying voltage divider method to obtain a standard form in terms of V output omega. Then j omega is substituted as h and the equation is simplified to its imaginary part and real part. The magnitude of the now called frequency response is evaluated. The phase frequency response is also evaluated and only the imaginary part is selected in the derivation. The types of transfer function is voltage gain. The type of transfer function is determined in this step and arbitrary circuit is also sketched with its source set to 0. This is to deduce the ratio of the output voltage to the input current of a mesh. That's all about the passive component, transfer function, and type of transfer function of voltage gain.
For part E. So first we need to construct the circuit as shown in the question. The used is 3 millihenry. The value of capacitor used is 0.33 microfarad and the value of resistor used is 12 ohm. For the function generator, we are going to start with a frequency of 1 kHz and the amplitude is set to 6 dB. The output voltage can be measured by using an oscilloscope. Once we have completed the construction of the circuit, we need to run the simulation. Next, we are going to view the waveform formed at the oscilloscope. It can be seen that there are two waveforms formed. The channel A waveform displays the wave at the source, while channel B waveform displays output voltage at the resistor. Since the question has asked us to measure the output voltage at the resistor, we need to check channel A to 0. Next, we need to press the single button to obtain a proper shape sine wave. Next, we stop the simulation and take cursor labeled number 2 and drag it to the Y max of the curve. Once it is set to Y max, the output voltage will be displayed over here. For the frequency of 1 kHz, the output voltage is 155.714 millivolts. So this value, or also called the output voltage, is then tabulated in a table of frequency and output voltage. This step is repeated using frequencies from 2 kHz until 10 kHz. So this is the tabulation of simulation results from 1 kHz until 10 kHz. It can be observed that there is a general increase of output voltage from 1 kHz until 5 kHz. The output voltage reaches its maximum at 5 kHz with 5.93 volts. And then From 6 kHz until 10 kHz, there is a general decrease in the output voltage. This can be observed due to the band-pass filter circuit only allowing frequencies of a particular range to flow through and reject frequencies that do not belong in the said range.
I am Nurul Najiha. My matrix number is B0821103666 and I will share about discussion for this assignment, and discussion is band pass filter is obtained by cascading passive low pass and passive high pass filters. This arrangement will provide a selective filter which pass on the cutting frequencies. Band pass filter circuit is designed by inductor, resistor and capacitor. The center frequency of the band pass filter, which is also termed as resonant peak, can be formulated by using below equation, which is Fc equal to 1 per 2 pi square root Lc, where L is an inductance of an inductor whose units are in Henry, and C is a capacitance of a capacitor whose units are in Farad. We can also design a band pass filter with inductors, but we know that due to high reactance and of the capacitors, that the band pass filter design with RC elements is more advantageous than RL circuit. The center frequency or resonant frequency at which the output is maximum can obtain by calculating the geometric mean of lower and upper cut-off frequencies, where Fr is the resonant frequency or center frequency. The ideal bandpass filter can also be used to isolate or filter out certain frequencies that lie within a particular band of frequencies. For example, noise cancellation. Bandpass filters are known generally as second-order filters, two-pole, because they have two reactive components, the capacitors within their circuit design. One capacitor in the low-pass circuits and another capacitor in the high-pass circuit. As for the conclusion, the bandpass filter is obtained by cascading low-pass and high-pass filter, either second-order filters, and it contains two reactive elements. The order of the filter depends on the number of cascading circuits using in the circuit. The gain of the output signal is always less than the input signal. At the center frequency, the output signal is in phase, but below center frequency, the output signal leads the phase with shift of positive 90 degree, and above center frequency, the output signal will lag in phase with the phase shift of negative 90 degree. The practical characteristics of the bandpass filter are a bit different with respect to the ideal characteristics. This variation is mainly due to cascading of high-pass filter with low-pass filter. The output gain is always less than unity. When we provide electrical isolation between the high-pass and low-pass filter, we can attain better performance of the filter. The band-pass filter will optimize the sensitivity of the receiver. The high-pass filter is first added to the design, later low-pass filter is added. Even though if we add a low-pass filter first and then the high-pass filter, it will never make change in the output signal. The quality factor of the filter will depend upon the resistor value R1. If R1 is the low, quality factor is low, and if the R1 value is high, then the quality factor is high. Sorry. So this is a few reference that we refer during while making our assignments. I guess that's all from our group. Thank you.